Alright, pause the video and try to do this warm-up real quick. Okay, we're back. Whoop, whoop, whoop. Gotta hit the marker. Again, always start off with the given. Then state the fact that we have a parallelogram ABC D. Okay, now I'll put these green marks to emphasize we're going to be talking about alternate interior angles. Okay, so being that this is a parallelogram and it has this transversal, that means we can state that angle, let's see, we'll do BAC is congruent to DCA, and angle DAC, see DAC is congruent to BCA. And we're going to simply say alternate interior angles. Let me capitalize that. Boom. Alternate interior angles. 3. I think you already see what's happening. We're going to mark this reflexive angle, reflexive side here. So we're going to say AC is congruent to AC, reflexive property. And we have enough information now. We can wrap it up with angle, side, angle, angle, side, angle. So prove triangle, see the proofs right there. So triangle ABC is congruent to triangle CDA. Angle, side angle. Now, here's the standards, questions. We're going to work toward isosceles triangles. So, CPCTC. Remember from yesterday? Corresponding parts of congruent triangles are congruent. So, take a second to copy this diagram again. And then, as always, I'm trying to save you time writing, so just go ahead and copy the given once under statements. Each other at O. And then given. Now, the fact that this says MP and NQ bisect each other, that means we can say that MO is congruent to OP and NO is congruent to OQ. So let's go ahead and write that. And if I wanted to, I can put each one on its own line, but I'm just going to combine them because, you know, I'm lazy and I'm trying to write as little as possible. So MO is congruent to OP and NO is congruent to OQ. All because of definition of bisectors. 3, we're going to argue vertical angles right there and there. So angle, we'll say MON is congruent to angle POQ because vertical angles. 4, the fact that we have side angle side, we can say triangles are congruent. I'm just going to keep up this angle pattern. So this time the triangle MON is congruent to triangle POQ, all because of side angle side. And look, our end goal is to get to MN and QP being congruent. Okay? But the fact that now these two triangles are congruent, we can finish it off with the proof, which is MN congruent to QP because of the new 5-letter word, CPCTC. And like I stated before, you've got to prove the triangles are congruent first. Let me get my highlighter. You've got to prove they're congruent first before you can use CPCTC. Okay? Alright. Let's keep going. Boop, boop, blink. Alright. Change my pen back. So again, copy the diagram in your notes. Again, it's always given. And I'm just going to start copying. And angle C is congruent to angle D. I'm about to burp, excuse me. Covered my mouth. Alright. Alright. So let's see what we got to work with. Let's mark it. AC is congruent to BD. Right there. CX is congruent to DX. Right there. And angle C and angle D are congruent. Right there. And look, I'm already looking at it. Side angle side is going to be what I'm going to put down next, because I already have enough information. So triangle, I'm just going to say ACX is congruent to triangle BDX. Okay, we're going to say side angle side. Well, with that information, that means all the parts are congruent. So now I can say that AX and XB are congruent. I need to state that first in order to say X is the midpoint, because remember, midpoint cuts these things in half. But I have to state first that AX is congruent to XB because of CPCTC. Now I can say that X is the midpoint of AB. And I'm just going to say definition of midpoint. Okay, remember, this stuff is using logic. You got to prove the congruent first before you can use CPCTC. Then you can finish off with your proof. Oh boy, I'm tired. Alright. Again, forewarning you, there's going to be an overlapping theorem of some sort for this one. But as always, copy the diagram and just go ahead and start writing your given, since that is always the first thing. Alright guys, I was delayed all day, but hey, I'm back at it now. So, let's see here. AB is congruent to CD, AE is congruent to FD, and angle, oh, yellow. Someone's been playing around with my settings here. Let's see. Blue. Alright, here we go. So, angle A is congruent to angle D. And again, all this is given. So let's see. 2. Let's go ahead and mark these things. A, B, and CD, that's right here and here. AE and FD, here, here. And angles A and D are congruent. Here and there. Okay? We are going to use overlapping segment theorem to prove that AC is congruent to BD. Okay? So, AC is congruent to BD because of the overlapping segment theorem. So now if we're looking at the bigger picture here, I have side, side, angle, side, this whole thing, A to C, And over here, side, angle, side. Again, this whole thing. So these two triangles are congruent. So we're going to say triangle EAC is congruent to triangle FDB. Side, angle, side. Now that it is side, angle, side, I can use that information to prove that EC is congruent to FB. And we're going to finish it off with CPCTC. Sorry, I was trying to do a line segment. Let me just try that again. For EC, because remember the last statement will always be the proof, typically, and CPCTC. Remember, CPCTC comes after you prove triangles are congruent, okay? Never before. And it's parts, meaning you're not going to have triangle symbols over here. It's either going to be segments or angles, okay? Let's see what's next. We'll skip these for now, and I'll do a couple of the, well, actually, the ones I assigned you, I have the answer key posted. So just reference the answer key for these. Alright, let's look at this. Given that triangle ABC, with AC being congruent to BC, AC, BC, prove that angle A and angle B are congruent. Hint, draw an angle bisector of the vertex angle and let it intersect the base at D. Angle bisector. Again, remember that means it's cutting the angle in two equal halves. So let's start off. We have 1, which is going to be given, so we have triangle ABC with AC being congruent to BC. And we made those marks. And again, this is given. I feel like the music's too loud. There we go. Maybe that's a little less. 2. So, based the fact that we drew an angle bisector here, let's state it. We're going to say that angles ACD is congruent to BCD because of the definition of angle bisectors. So now we have that. Can't we argue reflexive property in the middle here? They're sharing the same side. So line segment CD is congruent to line segment CD. And this is going to be reflexive property. There we go. So we have a side, angle, side, side, angle, side. I think I can go ahead and prove these two triangles are congruent. Smaller triangles, that is. So ACD is congruent to triangle BCD because of side, angle, side. Now that we have two congruent triangles here, that means all their corresponding parts are congruent. So now I can make the jump to angle A is congruent to angle B because of CPCTC. Now that we have that, oops. Guys, I just broke my, what do you call it? My keyboard. Alright, fixed it. There we go. And if you notice, this is going to be an isosceles triangle. So now A, B are congruent to each other. Hence, isosceles triangle theorem. If you have two legs that are congruent to each other, that's in a triangle, then their base angles are going to be congruent. Same thing if we go with the other direction. If we're given two angles that are congruent in a triangle, then their opposite legs are going to be congruent to each other. Okay? So, again, I should have the answer key on Google Classroom for you, so just reference it for this worksheet. Okay? Let's see. I think I skipped Pikachu. Where did he come from? I think I did these in class. I think I skipped these, though. Yeah, maybe I did. No, we didn't skip these. I think I skipped these, so we'll work these out. Okay? So, I have 48 degrees right here. This angle and this angle are a linear pair. So that means if you get your handy dandy calculator out, you can go 180 minus 148, and we'll get 32. So this angle will be 32. Now, being that this red square makes this whole thing 90, well, then that means I should just be able to go 90 minus 32. We get 58. And if this is 58, this leg's congruent, this leg's congruent, that means this has to be 58. And since these two angles are a linear pair, that means they add up to 180. So now I can go 180 minus 58. We get 122. Boom. Let's look at 12. Again, linear pair. This is 120. Doing some mental math here, it must be 60 on this side, because 120 plus 60 is 180. And if this is 60, that means our leftovers is 120. Divide that by 2, we get 60 and 60. Okay? And all that adds up to 180. Looking good. Vertical angles, which means that's 60. These two are base angles, which means they're 60. Again, vertical angles, 60. Huh, neat. 13. Let's see here. This is 8, that means this is 8, because they're opposite of each other, as far as the legs of this isosceles triangle. And if these angles are congruent, because it's just one tick mark, then that means this is probably going to be 8, and all this should equal 8. So now it's just a matter of solving that equation. Add 1 to both sides. X equals 9. Skadoosh. Let's see. Let's see here. Got a tick mark here. Angles. These two have got to equal each other. So let's add 12. Add 12. 24 equals 2x, not tx, I don't know what I was saying. Divide by 2, and we get 12. 12 equals x. Then like that. 12 equals x. Let's see here. Again, you can reference the worksheet, and I worked this in class. There's Pikachu. I guess that's it. Alright. We're done with that one.